Okay, and this one is a, what type? Exponential. Exponential, decay. What about D?
Linear.
Linear, looks more like a line, so linear. What about E? Linear. What about F?
Quadratic.
Quadratic. There we go. Okay, so let's turn it over and get our Desmos ready. Our calculators can produce equations of exponential best fit and quadratic best fit, along with a lot of other types of curves. So exercise 2, biologists are modeling the number of flu cases as it spreads around the particular city. It's a little outbreak. The total number of cases was recorded each day, okay, X, after the total first reached 16 cases. Okay, the data for the first week is shown. Okay, so starting at 16 cases, 1 day later, there's 18 cases, so forth. Okay, so use your calculator to find the exponential regression equation for this data, and this is y, so exponential is y equals a b to the x. Okay, so when we type in, well, let's go ahead and put our table in. So back to Desmos, okay, plus table. So type in these values for your x and your y. So I'll get those in, 0, 1, 3, 4, 6, 7. Type the y values. 16, 18, 22, 25, 33, 35. Okay, and so they're all right about there. Okay, you guys got those in? Okay, and then we're going to use an exponential equation over here to best fit that shape. So I'm going to type that in down here. Okay, so to type this in, do we put y or y1? Y1. And again, the only reason why we do that is because up here they put y1 and x1. So we got to use those same ones if we want to use this table. So y1 is approximately equal to, okay, a b to the x. So a, and I don't think we have to put parentheses there, because I think it does order operations as the x1 at first. So I'm just going to put a, I'm going to try just b, and then now to go to the exponent, to the x power. So I need to put the shift on, like you're going to type in capital letters. So this little up arrow, push that up arrow, and then you'll see a to the b power. So type, push that, and then I want this to be to the x, or x sub 1. So let me get off my capital letters, right, and push x, and I got to go to my numbers, and then 1, and then there you go. There's my exponential best fit curve. Okay, do we all get that? Okay, again, to get that exponent up there, okay, you have to push the this up arrow thing there for the shift to go to like all capital letters. Okay, push it. So a to the b power, and then you type in your x sub 1. Okay, so let me see what they gave as your a and your b. So let's write this down. Okay, so round all parameters to the nearest hundredths. So it's y equals a, which is 15.91, b, which is 1.1212 to the x. So that is our equation. That's our equation. Okay. Do we get that? All right. And so b, okay, based on the regression equation, how many total cases of flu will there be after 2 weeks? So if after 2 weeks, what do we need to plug into our equation, what would our x be? 14 days. Okay, so we can use A and B because it's already defined up there, your A and your B. So I'll just use A, B. So I'm going to type in A and B, and I'll do that up everything, and then we want 14. So let's see if we could type that in. Okay, so oops, small letter A, B, let me shift to the number 14, and there we go. Okay, so after if it keeps this pattern, the number of flu cases, okay, that's going to be, what did you guys get? 80.06 flu cases. Okay. So this is an exponential growth. So if you go further out, like 3 weeks or 21 days, it's going to go way high, skyrocket. Okay. Okay. C. According to your model right here, by what percent are the flu cases increasing on a daily basis? Okay, since this is bigger than 1, it's a growth. Okay, the number of cases increasing. Okay, the 1, if you just multiply or 1 to some power, it stays the same. That's the way I look at it. So what percent, so forget the 1, what percent do you think this is increasing by? 12%. Okay. So just go from there. So 0.12, but change that to a percent, move it over twice, right? So 12%. It's increasing by 12%. Okay. Okay, D, hospital officials would declare an emergency when the total number of cases exceeds 200. Okay, on what day will they need to declare this emergency? Okay, so way up here, when there's 40 cases, 60 cases, 80 cases, 200 cases, we want to know which day that's going to occur down there. Okay, I believe we could, on our equation, where would we want to put the 200? In the X or the Y? The Y. Y is the number of cases, 200, then they consider that an outbreak. Okay, so I'm going to try this. I'm going to type in Y. I think I need to put y sub 1. Let me just try that, y sub 1. And I'm going to push equals now. Equals 200. Okay, so it didn't give me anything, but I'm going to go up on my graph, and I think I can just touch up there at 200. So let me go to my graph. Go up there at 200. And my x value, what happened? Yeah, let me just type in y then instead of y1. Let's see. Okay. Yeah, I'll type in y is equal to 200. Yeah, actually y1 would be right on our graph. So let's type in y is equal to just y equals 200. Let's go up to 200. And then if you just touch it, I think it'll give us no. And then it should give you the. So press and hold. Oh, okay. Oh, there we go. Okay, so if y is equal to 200, so x equals 21.932. So days. So after 21, almost 22 days, okay, you're in the 22nd day, but after 21.92